want to build ourselves a toolbar. So we've got, we declare ourselves another module, we build ourselves a toolbar. One of the things we found whenever we were building Blueprint Registry is doing things in terms of factories and thinking in terms of factories for building the UI. So we have the toolbar layout, and then we have two different views for the toolbar. We have, when you're logged in, you certainly see a different portion of the toolbar than when you're logged out. We have different menu items, different behaviors. So we kind of encapsulated all of that into a factory that just says, okay, listen, we're going to load the toolbar. This is how we scaffold up the toolbar and create it, completely self-contained, not within the context of anything else in the application. This is how we assemble it. And then with the way that Marionette does its modules, so you see we did earlier here, you see the app.module, we declare a toolbar module. We can say for the toolbar module, on start, or whenever the application is started up, it'll fire the start event on all of the submodules that you've defined. So on the start, it's time for me to run the factory, show whatever it produces, and then go ahead and start listening to events on the application saying, now that we've booted up, I want to listen to, has the login or logout state changed in the application, because I need to make this area of the application respond. And so now what we have here is a completely self-contained toolbar system that can respond to the application depending upon what's happening elsewhere. Our auth system is completely disconnected from the toolbar. The toolbar is just listening, hey, am I logged in? Am I logged out? That's all it cares about. I'm not tied in. It's self-contained. And then, so as we continue, one of the things, you still, even though it's a single page app and you're trying to build this application that it's basically a single packaged JavaScript application, there's still the concept of functional pages, and you don't necessarily want to completely move away from that concept, especially if you're just getting into single page applications. You think of your existing request response cycle, I'm going to this page, you know, I'm in the registry creation page, I'm in the registry view page, I'm in the registry manage page. You don't necessarily need to completely break away from that ideal. And so we tried to reflect that behavior of the application in how we organized and laid out the modules. So we have our module for creating a registry. We define Marionette. We have doing the layout, and you can see we extend the Marionette layout system, which Marionette provides us an easy way to attach a handlebars template, give it a class name, define a region where you can attach views. And then we have a smaller sub-view where we say, here we've got the form layout, it has its own template, it also has its own regions. We kind of nest further downwards, and you see that we start listening to events. And so we go in, and the same system here. We go, okay, now we have a factory that says, okay, listen, if I want to view a registry creation page, how do I assemble it? I have my individual components, I have the layouts, I have the views. We take the factory that says, this is how we actually assemble and put everything together. So we sit here, we create our model, we attach it to the layout, we attach the breadcrumbs, the form, and then we say, hey, listen, whenever the layout's rendered, we need to attach all of the views, which is something that we learned when using Marionette. If you decide to start playing with it, you can't just attach views willy-nilly to a layout. You have to make sure they get attached on the render, otherwise there's nothing going to be to attach it to. And then finally, we utilize an extension that Marionette gives us is a nice unified controller system. So this is where, defined entirely within the create registry module, we say we have a controller which would be completely analogous to what you would consider a controller action on your server side, saying we want to trigger the create registry action. Whenever we go there, we have an internal utility which is just a wrapper around the backbone navigate function that says change the, do a push state to say we're now looking at create-registry. So we have the URL /create registry. We trigger an event to communicate with the toolbar system, but we say, okay, let's display the layout, and then we set up the router to say, hey, listen, if you ever detect the URL create-registry get hit, you need to call this controller. If as you go through and you use Backbone Marionette and these kind of systems in your single-page app, that's a pattern I would suggest that you go about is that internally, whenever you're working your application and you transition between states, what you want to do is you want to call individual controller methods. So if we were to be in another section of the app and we wanted to go and said, oh, the user triggered an action, which means we need to send them to create a registry, which is effectively they click the create registry link, we literally just call we want to grab the create registry module and trigger the create registry action on the controller, and it automatically goes in and it blows away whatever was sitting in the main layout, and it goes through this entire process through the factory, creates it, and replaces it. And I've talked about this a little bit, and I really kind of want to go through and reinforce kind of the $2 word of the day. Impotent, which is a word that is used very, very often if anybody has ever done functional programming. Impotent means you have a method with absolutely zero side effects. If I pass in the same arguments into this method, I will get the same results every time I run it, no matter what happens, meaning it's not modifying global state, it's not doing anything. If I pass in, whatever I pass in, I get the same results every time. And that's going to be something that you're going to want to make sure that you're absolutely keenly aware of that you're doing when you do a single-page app. There are a lot of hacks and things you can get away with when you can rely on the entire global page state of your application getting completely blown away by a refresh or a page transition. You can't rely on when you have a single-page application, when you have the same JavaScript and the same structure running for extended periods of time. So you want to make sure that your individual views, your individual modules have an extremely limited scope of responsibility. They only deal with themselves. They only deal with their own internal jQuery object that references the element that it's managing. It only binds events to anything that it is a child of itself. And if it needs to communicate outward with the application, the object will fire events that the parent containing views can listen to. So you want to make sure that, you know, as you write your view code and as you assemble your application, that you don't do this. You don't, if you see anywhere in your views in your Backbone application where you're actually calling a global jQuery function, you should stop doing that. It's going to cause bugs because you think to yourself, oh, this works, this is great, I just bound an event on an element. Well, you leave that portion of the section of the site and you come back and that code, that scaffolding code, gets called again. Now all of a sudden you have two event listeners listening to the same element, and you have code getting called twice, and you start thinking, huh, it's kind of funny, my stuff breaks the second time I visit it, not the first time. Why is that? You want to make sure you utilize the internal functions that Backbone Marionette gives you. This.el, which is a link to a jQuery object pointing to the container that the view represents, and you want to run your events on there so that whenever the element gets destroyed and pulled from the DOM, the event listeners go with it. And you don't have to worry about rebinding event listeners. You can continue to create multiple copies of this component or this view without having to worry about any kind of leakage. Same thing that you probably won't be aware of too much is a lot of your views are going to get models passed to them. Here's the model because I need to know there are certain values of the model that I need to reflect in the UI. And you'll think to yourself, because Backbone is an assemble-it-yourself Lego type of framework, and you have to bind the listeners yourself, you're going to think, I'm going to listen to this property change, I'm going to listen to change on name, and I'm going to update the portions of the UI based off of that. That's not particularly good because as you garbage collect that object and throw it away and come back, you now have a model that has continued event listeners stacked on top of it as you continue to re-execute. And thankfully, in more recent editions of Backbone, they give you something called listen to, which inverts the responsibility of who's listening to events. The event is not bound on the model, the event is bound on the view, listening to the model, ensuring that when the view gets destroyed, you're able to, all of the event listeners go with it. But if you do have to cheat and you do have to listen to an event that you can't get isolated, like I need to listen to resize in order to make UI changes for the responsive portion of the application, you know, just make sure that you're cleaning everything up. Marionette provides a much easier way of getting event listeners for whenever your elements are cleaned up and removed from the system. So I open a view, I'm going to put a throttled listener on window for the resize event to make sure that I react accordingly, and then on close, I just make sure to unbind it, and I make sure that the event listeners are namespace to that particular model. Completely isolated, completely idempotent. I can create a million different copies of the component, and then garbage collect all of them and create another one, and every single one of them will perform and operate exactly the same because they did not interfere with the other ones. That's just good practice even if you don't use Marionette and you're not doing a single page app. You want to make sure that you're not being very leaky. So one of the concerns that I had myself when building a single page app, but a lot of people do, is we're doing this, building this experience. What about that initial page flicker? What can I do? So this is great, but you know, you have that flash of unstyled content when you load a page. So here, at some point, you can build your application, it can be nice and fast, and then you got to start dropping down and reiterating and optimizing. One thing that we found that was massively helpful that we built in a little bit earlier is preloading data. So you know that, so you build a single page app, it's the same set of JavaScript that executes no matter what URL you hit in your application. I go to view a registry, it's going to load up and it's going to fire an AJAX request to get all the registry information back. Well, I know the URL on the server side of where I'm going, and I know what REST URL I'm going to hit in the back end. Building your application to be aware of preloading data. So as I go to the view registry page, I'm going to sit there and I'm going to go internally, I'm already on the server, rather than round tripping, I'm going to take the data that the REST API would have sent to the front end and drop it straight into the HTML that I'm delivering downward, and writing code that says, I make sure I centralize all of my object fetching to say, hey, listen, have I preloaded this data in the initial page request? Yes or no? Yes, I have. I haven't used it before. Let's return that rather than making a round trip to the server. Pretty much eliminated 90 to 95% of that flash of unstyled content that you get with single page apps that don't pre-render their content. So to circle back, that was obviously a very brief introduction of kind of how Marionette can be assembled into a modular architecture, and clearly limited with 30 minutes, I can't go deep into depth, so ask me questions later if you want to see stuff. The big thing that I wanted to talk about with Require.js, and one of the things we were able to do, and the reason why we picked Require.js over just doing our own modular system or whatever, was a tool called RJS, which is distributed by the Require.js guys, which is this awesome little CLI utility that runs through Node that will actually sit there, take your application, completely resolve the dependency tree, assemble and concatenate all the files, or all of the contents of your dependencies into a single file for you. So as long as you actually build out your dependencies as a tree, RJS can actually assemble that single JS file for you. And you want to deliver a single JS file as nice as the concept of asynchronously loading your 20 or so JS files that your application lives in, as nice as it sounds to load those in asynchronously, that's actually a much more of a performance hit than you would get loading in a single file. Even though that single file is larger, you can put cache headers on that single file so that you only load it once, and you're not waiting for any kind of resyncing on the threads for everything to come in. So we used Require.js because it allowed us to, in dev mode, we were able to run the same exact architecture with minimal changes. So in our templates from the server side, we say, are we in dev mode? Yes, just load in your traditional Require.js, you know, that system, so we can actually sit there and make the dynamic calls to the our dependencies. Or if we're not in dev mode, go ahead and load up the minified and gzipped version of the JS file for absolute rapid customer experience. And it gives us the single HTTP request, a single cached file that we deliver over a CDN that we can deliver blazingly fast. And we can actually go through in and with RJS, we get a lot of benefits. We're able to do even further optimizations. So there's a utility, there's a library called Almond JS, which is basically require.js, but without any of the code that has to do with firing back-end requests to load in your JS dependencies. It's literally just defines the define and require functions, and that's it. So significantly smaller code footprint. So in our build file, we say when we build our final build application.js file, don't include require.js. That's a few extra kilobits we don't need. We're going to use Almond JS, which is just going to have a shim. We tell RJS to find our nested dependencies. Don't add the license comments. We'll have that elsewhere. We want this absolutely as slim as possible. We're going to tell it by default, it'll run it through a minifier, either like closure or YUI compress or something like that. And then we can do Pragmas, which are these nifty little things where you can sit there and say, you can give, for a Pragmas, you can give comments in your JS code. And one of the things we actually did was we went through in and the source for, the source for Mustache, we went through in and we put Pragmas around certain portions of the source code. So all of the code having to do with the AST system and the compiler and the parser for handlebars, we completely ejected and don't include in the final build. The only thing that's included in the final build is just the runtime for handlebars. And the reason why we do that is because adding in yet another utility to require.js and RJS, the handlebars template loading system, which you might have seen earlier with the HBS exclamation point and then the location of the template, allows us to actually take our handlebars templates and pre-compile them and concatenate them straight into the JavaScript in their modular format. So we actually, in our build process, we assemble all of our dependencies, we strip out code that is not necessary in production, which are compiling and those kind of functions, and we also pre-compile all the templates, so we don't waste any CPU cycles producing JavaScript code for the templates. We have the pre-compiled handlebars templates with all of the helpers and everything like that inlined at the end. And by doing all this, after triggering that, we do that, we ensure the compiling. After doing all this, what we end up with is an uncompressed file of about 1.2 megabytes, a compressed version, a minified version of about 626K, and then after turning on gzip compression on the server, we serve down a 137K file that we serve on the home page with infinite cache heading, telling the client to please never download this file again until I ask you to. And voila, we've basically eliminated most of the entire flicker or any kind of lag on the first visit of the file. So that kind of covers basically what was going on, but I kind of want to give you guys just a quick, just to kind of give you an idea what's actually going on. So we load in, like I said, talking a little bit, just finalizing on the optimization. One of the things we do, like I said, is this is one of the few pages where we actually have the content statically on the servers. So we actually serve up the home page rendered traditional style. However, we have our, we load in our application.js file, which takes over the content, doesn't quite do anything with it. So this ensures that the first time they visit the site, they see content. The JS file is deferred, so we load in the JS file, the 137K, however long that takes to download. And then from there on out, every subsequent refresh, the browser's hitting the cache, and the application is already in single-page app mode, and we are not having to deal with any sort of flicker. We are officially in single-page app mode, where now the server, if we were to direct link to that, we're not sending down any content except for data that we preload about the registry, and voila, you have a single-page app that is quick and easy for us to develop as a team and to keep everything nice and organized and rapidly developed, and a client that was very happy that we were able to push the site out in a very, very short amount of time. So Thank you. And then, like I said, I highly recommend these books if you're thinking about possibly using Marionette and Backbone as a tool chain for your single-page apps. These books are really good, at least as giving you an example of what a larger application would look like, so, as an example. So, there you go. Do I have time for questions? I can take a